Hello, everybody. Welcome to the FlowCAD webinar Tips for Working with PCB Editor. My name is Petra, and I will assist my colleague Holger Schröter, who will show you useful functions and tricks that make your life easier when working with PCB Editor on a daily basis. If you have ever had contact with our support or attended a training, you probably already know Holger. Some words about him. He has studied communications engineering and has many years of know-how in PCB design for various applications, as well as design flow development and support. Since 6 years, he is working as application engineer at FlowCAD. That's enough of introduction. Holger, let's get started.
Good morning also from my side. Thanks for the introduction. So when I prepared this webinar, I made my mind up. So what are regularly asked questions on our hotline? Also, I was discussing this with my hotline colleagues, what they think would be useful tips for the PCB editor. I also made my mind up what are regularly asked questions during the trainings I'm giving. So, and I collected a bunch of different topics. I hope everyone finds some interesting things for him. Let's get started. We will talk a little bit about the installation, about setting up the tool, about different editing features, maybe also some things which are a little bit hidden inside of the tool. We will talk about shapes, then also a little bit about the constraint manager. Bigger topic will be XNets in the end. And yeah, this is the collection, and I hope everyone finds an interesting topic for him. So let's start with the installation. Sometimes we have strange behavior reported by a customer, and in the end it turns out that these guys are still working with very old releases, so sometimes even base release of 17.4 or even 17.2 sometimes. So our recommendation is keep your installation up to date. So these hotfixes are not coming out just for fun. They are really fixing some issues, and therefore you should always keep your installation somehow up to date. So you can see this when on the starting page inside of the PCB editor, or also you can see this inside of the download manager, whether you are up to date, because then it's this updated screen here then inside of the download manager. So that's the first thing here. Good. Nowadays, screens are getting bigger and bigger, so I bet that sometimes some of you guys already have a 4K monitor or something like this. With this very high resolutions of these screens, everything gets really small and tiny. So, and therefore, Cadence invented this environment variable. Excuse me, Windows environment variable, and you can set this, and everything is optimized for these bigger screens. So, and everything will be better visible, better readable, and so on. With this also, there are some environment variables or user preference, I must say user preferences facing similar issues or solving similar issues. So one thing is the font size. Under setup, user preferences, UI font, and then the font size. And you can make the font size of the tool bigger. This is also what I do, because I'm a little bit older in the meantime, and therefore my eyes are not the best anymore. And for me, this is easier to read everything inside of the tool. And the second thing is here in the user preferences is also the size of the icons. You can change this, you can make this bigger. This actually I never did, but please feel free to test this, whether this is nice for you. So in searching for this inside of the user preferences, I mean, this is somehow obvious. A little bit more hidden is the setting for the constraint manager and also the analysis modes, because the font there is also pretty small. And this you can increase under view options and workbooks, and then you have this font thing here, and you can make the font, especially for the analysis modes, bigger inside of the constraint manager. So this you have to keep in mind here. This is really a nice thing. I also did this because these fonts inside of constraint manager and also analysis modes, they are really pretty tiny, and it's easier to read if you make them a little bit bigger. Good. All these settings can be saved. So the canvas setting can be saved, especially if you, for example, work in the office with 2 big monitors and sometimes work in home office just with your laptop display. You can optimize your settings and optimize also the different tabs here where you move them, maybe move them to a different monitor, to a second monitor or something like this. And all this you can save. This is under View UI Settings, and then you can save your personal settings. For example, I have here my canvas settings. And what you can also do is resetting to the default. So again, under View UI Settings, and then reset UI to default, then the normal cadence default is coming up again. And everything will be there on the normal place, so to say, inside of the tool. So this is also a nice feature, and especially keep this in mind if you regularly change between two monitors and just a laptop display or something like this. Good. So much about a few different things regarding installation, setting up the tool. Let's talk about editing feature. So, and first thing is here talking about a little bit of, again, user preferences, setting up some things. So sometimes, especially experienced layouters, they are really fast, click really fast inside of the tool, and sometimes even too fast. So and then it can happen that you start routing in open space, so to say, without any net, without routing starting from a pin or something where net information is coming from. And then you have, a stupid copper line, but no net on this. And this can be avoided by, again, a user preference. So under user preferences, route connect, there you have a user preference which is not allowing this, so to say. And you always have to start on a pin or a via or whatever. So this is sometimes a nice setting. And what is even more important from my point of view is the snap to connect point in the routing options. I see this often inside of the trainings. People are playing around with the different settings when they start to learn how the routing is working and disable this. And then they start somewhere on a pin, but the net is not really taken over from the pin. It's not really connected. And they wonder why the tool is behaving strange. So our recommendation is always leave this on, leave this enabled, this snap to connect point. I will show this later also in the tool. Then you have an impression how this is reacting. Good, so these were more or less features which is quite obvious. So in the routing options, there are some additional editing features which are not really under editing, but under manufacture, here under manufacture and then drafting. But they are sometimes really useful. And by this manufacture drafting, a little bit hidden, I would say. So I will also show this inside tools. Is, for example, this delete by rectangle is quite nice. Also add parallel line is quite a nice feature. And since it's here under manufacturing, it's not really obvious that these commands are really available there. But sometimes useful. I will also show this inside of the tool. Also, another nice feature, nice editing feature is edit change. There you can change different things, for example, line widths, for example, the text block and so on. And also what is really powerful is changing the subclass. So you can very easily, with just one mouse button click more or less, put a bunch of connect lines to a different subclass. And what is really the nice feature there, the vias are also added automatically. Drawback here a little bit is no DSC aware. So you can easily also generate DSCs inside of your design. But overall, this is really a nice feature here. Good, and another thing, experienced users are aware of this, I'm pretty sure. But more or less for the new users, Snap Pick 2 is really a nice and powerful feature. And if you use the Snap Pick 2 on the right mouse button, click inside of a command, then you see you have quite a big list of different objects to where you can snap the mouse cursor. And this makes life very easy, and is very precise to work with the tool with the Snap Pick 2 functionality. Then always adjusting the grid or something like this would also be possible, but this is a really cumbersome thing. And this is really easy and fast to use this functionality. I will also show this inside of the tool. And then you have an impression how the Snap Pick 2 command works here. And almost all commands is available on the right mouse button. Good. Again, editing things. So inserting text. This is also possible to insert text from a text file. So read from file, also right mouse button menu. One thing you have to keep in mind, you have to select the position first and then use from file, because the other way around is not working, is grayed out. So first select this location inside of the board, and then right mouse button click, read from file, and then you can add this file, or this text from the file, from the text file. Good. Yeah, then after these few editing features, coming to the shapes. I have some slides regarding shapes. So first, there's also, again, user preference, which allows you to change the visibility of the shapes independent of the edge visibility. This is also sometimes really nice and useful. So normally you turn off everything, turn on everything, every edge thing here. So routing and shapes. But with this additional column here, you can also just make the shapes invisible. This is sometimes really useful. Good. So then, since also this has been enhanced in the meantime by this layer dynamic parameter, let us talk a little bit about the priority of the settings for the shapes. So I'm pretty sure most of you guys already know you have the global dynamic parameters, which is the lowest priority in setting up some things like the thermal reliefs. And then we have in the meantime now the layer dynamic parameters, so for individual layers or also for layer groups here. And then for sure, shape instance parameter is also possible. So right mouse button click after you have selected the shape, and then instance parameter, and then you can change really the one dedicated shape. And even more high priority the properties have. So they are overriding everything. And what you see here, I showed this here on the right side. So for example, here from the global dynamic parameters, orthogonal connection is coming here for the SMD pins. So from the layer settings, layer dynamic parameters are overriding this, and from the layer dynamic parameters here, in this case, diagonal connections are coming up. So, and if you want to override this for one dedicated pin or one dedicated via, for example, want to have this full contact, then you can do this by a property and adding this property to this via or pin or whatever. I will also show this later on inside of the tool, so then you have an impression how this is reacting. So, and keep this in mind, how the priority is here of the settings. Good, adjacent layer cutout, sometimes required in high-speed designs. So cutting out the ground plane underneath a high-speed trace, or especially underneath an SMD pad of a high-speed signal. This can be set up basically inside of the pad stack editor. So there you have here this keep out and adjacent layer. So there you set this up, so this size basically of the cutout, and then you have to activate this inside of your design again with a property, and this property is here adjacent layer keep out below, also possible adjacent layer keep out above, and you enter a value here, and that's exactly the number of layers which are cut out under this SMD pin. This is quite a nice feature. I will also show this inside of the tool. And then you can automatically, or not automatically, but by setting up a property cutting out the ground plane under an SMD pad, for example. Good. If you want to route sense lines with the same net inside of a shape, then there's again a property. So we will talk a lot about properties today. And this property in this case is void same net. So in this case, you can see here, you can route a sense line which has the same net here, VDD in this case, connected at a dedicated sensing point, but the rest is here, cut out. And this property is controlling this. So then the C line is not connected or just connected on this dedicated spot, and the rest is cut out from the shape. This is also sometimes really required to have sense line routing. Good. Then we have sometimes the need to have wider or smaller spacing between a C line and a shape inside of a region. So normally the most conservative value is used here for cutting out this line. So here's this region on the right side is the region. If you want to really have a tighter spacing like this here below, then you can use a property again, on the complete board drawing. This is this thin shape void C-line region. And then this is behaving like this. I will show this also inside of the tool. And what I would mention, many people are not really aware that they can also set properties on a board drawing, on a complete board drawing, or even on a package drawing. This is also possible. So in this you have to keep in mind here, and I will show this later on. Some time ago, there was a user preference for this. I would not recommend to use this anymore because drawback of a user preference, this is for each and every board you open because it's your user preference, right? So and therefore controlling this by a property on the board is more powerful, so to say, or better way than in the user preference. So that's why we do not recommend to use this user preference here anymore. I will show this also inside of the tool later on. Good, negative artwork. We get sometimes boards on the hotline behaving strange, and especially having lots of DLCs inside of the shapes and doing update shape and everything and database check and so on and so forth. And nothing can remove these DLCs. So in the end, often it turns out this is negative artwork. So inside of the cross-section editor, guys has set this to in the physical setting to negative artwork. Yeah, and then it's negative. So and for sure, everything what is kappa in the board drawing is then in the end nothing inside of the Gerber data. So inverted negative. And our recommendation is do not use negative artwork anymore, because this is really an ancient technology to use data size for Gerber data and these kind of things, and it only makes your life complicated. Nowadays, the size of the Gerber data doesn't matter anymore. So in all this stuff here, also inside of the pad stack editor regarding thermal pad and anti-pad and so on, this is not required. You only need this when you use negative planes, and yeah, that's why our recommendation clearly is do not use negative artwork anymore, because it's simply not required. It makes things complicated. So net shorting. This is also sometimes required to have a dedicated shorting point, for example, to short an analog ground and ground earth nets or something like this. At a dedicated point, not always connected. So, and this you can do again by a property, net short property, which can be used on pins, vias, or shapes. And what is important when you set this property is this nomenclature. So there has to be a column as a separator between the different nets. Can even be more than 2 nets for sure. So and then you can use this on a pin or something, and then this will be shorted at one dedicated point. And also this can be combined, for example, with the dynamic thermal con type, like full contact or something like this. So this could also basically be used together. So if you want to. I will also show this inside of the tool, how the shape in the end in my example will behave then when we set this net short property. Good, this is quite also frequently asked questions on the hotline. Normally the power nets, the red nets of the power nets are displayed in this fashion. So with this square with a cross in the middle. So, and some people don't like this display of these redness for the power nets. And you could basically remove the voltage property from this power nets, but this I would not recommend because the voltage property is controlling different other things. I will talk about this a little bit later when we are talking about the XNets. And therefore, this voltage property should not be removed, but instead of this, we can set a redness schedule on the power net, and then it will also be displayed like a normal net, like a normal signal net, if you want to. So, as mentioned, some users don't like this display and want to have the normal display of the redness also for the power nets. So again, a property for this. Even more properties, locked and fixed. So fixed property with these nails here. They prevent from moving something inside of the board or deleting something from the board. In addition to this, we have the lock property. And if the lock property is, for example, set on a symbol, the symbol can still be moved inside of the board, but the child elements of the symbol, for example, the place bound or something like this, cannot be deleted or moved anymore. And this, prevents from destroying some things. This is especially useful for modules, because imagine you have designed a module and want to use this in different boards, so then the module should be somehow locked to not destroying the modules by fault when it's used in a different board. Good, so this is difference between locked and fixed somehow. I will also show inside of the tool. If you have questions or want to look up some things regarding the properties, you can do this under help. There is this Allegro platform properties reference. There's also inside of the installation in the doc folder this prop ref document, the properties, HTML. This you can also simply open, and there are all these properties are listed. Don't ask me how many. There are hundreds, I think. So, and in many cases you will have to have a look at this properties reference document to really see what the different properties are doing. Good, then sometimes somehow a little bit stupid fault which you can easily run into. People sometimes set up some things inside of the constraint manager, but simply forget to activate the checks. So this you have to keep in mind. Just setting up something is not sufficient. You also have to activate this here in the analysis modes, or even here in this header cell. And keep in mind, when the header cell is yellow, the check is turned off. And here, this one is turned on in the analysis modes. So please keep this in mind. Checks also have to be turned on, otherwise they will not for sure not work. Good, and then small trap. When you are working with the same net spacing constraining, you also have to enable these same net spacing checks here by enable DRC by layer here. So this is one thing which is not really in the analysis modes, but here directly inside of the constraint manager. And this is actually a trap. I run into this once a year or something like this. So because I simply didn't remember to also enable this here. You have to keep in mind when you work with the same net spacing checks. Good, constraint manager objects quite also frequently ask questions. What's the difference between a net group and a net class? So a net group is basically a hierarchical element collecting different things together for easier constraining or something like this. And the net class is typically used for net class to class relations. So that's basically the difference between these two objects. If you want to have a little bit more information, we put a small application note here on our homepage. If you get the handout here of this PowerPoint and PDF form, then you will also have this link and can have a look here at this application note. In the end, there are also some additional links to our application notes and some other documents, which you can find here on our homepage. Good, then a little bit bigger chapter is the extended nets thing here. So what basically is an XNet extended net? It is in the end a net which is running through a component. So you see here, we have the driver here, we have the receiver here on the right side. And these two nets here, net 1 and net 2, they form an XNet through this passive component R1. So the name of this XNet is by default then again net 1. That's how the tool is naming. So alphanumeric, the lower net name is used for the extended nets. So in these XNets, they are generated automatically by the tools. You don't have to take care about this. The default methodology is this will be generated automatically by passive devices, through passive devices, and through devices having the XNet pin properties. We will also see this on the next slides. So, and yeah, that's the first thing. And many people wonder why I get these XNets. I don't want to have them. I'm maybe also a little bit afraid of this stuff. We will talk about this a little bit on the next slides here. So, and when you want to control these XNet visibility inside of the PCB editor, we have the objects filter. I will show this also in the tool. And we have here then the possibility to display or hide the XNets and also display or hide the nets inside of the XNets. So that's the first basics regarding the XNets. Let's come to different things here. Again, coming to properties controlling the XNets. So first, voltage, I already mentioned this. The voltage property is controlling or somehow limiting the XNets generation. So imagine here this same example again. Driver, receiver, and one XNets running through this resistor R1. So now if you have, for example, a pull-down resistor, second resistor here to the ground nets, basically, and there would be a huge XNet be generated, also including this ground net. And this doesn't make any sense from electrical point of view, because you want to constrain, for example, propagation delay from the driver to the receiver just through this line here, through this XNet. So, and that's why the voltage property is stopping the XNet generation, which makes perfect sense. So this is the first thing you have to keep in mind here. Then we have two different possibilities controlling XNet generation. So this first thing is no XNet connection on a component. Then this is also not generated. So for example, if you put here no XNet connection property on this R1, there would be no XNet generated here. So and the second thing is here XNet pins. And for example, here I put the XNet pin property here on this one guy here, on this pin, also on this pin, the same one. And then here will be an XNet generated through this active component in this case, from this net 1 to this net 5, which is then in the end called XNet net 1. So these are the properties controlling the XNet generation. Good, and then there is a possibility, normally this is not required and not really recommended to change the XNet generation flow, but then basically it would be possible, but it's hidden somehow. So there's an environment variable, is CDS XNet state UI. If you set this environment variable inside of the constraint manager of the PCB editor, we have these options here. And we see here the default port possibility or methodology, how the XNets are generated, is this create XNet for passive devices and for devices having XNet pin properties. So normally with this you are fine and you don't have to take care about anything. If you really want to change this, we can also change this by only for XNet pins. Or to the old flow, the DML model-based flow. But then you have to keep in mind, yeah, okay, I have to set up DML models for all the components so that my XNet generations are really created as I want to have them. So, and yeah, that's why we do not recommend to change this at all. Always stick to the default flow, and then you're fine. So, and especially you have to be careful when changing the flows, because then the tool sometimes is adding properties. For example, if you switch to this XNet pins flow, then to maintain the XNet pin properties are added. Or if you switch to the DML model-based flow, every XNets will be removed from this complete design. So, and therefore you have to be a little bit careful when you really switch the flows. So this is regarding XNets so far. So then database check. There's also this possibility to regenerate the XNets. This is sometimes required. Yeah, and in the end, normally run database check before manufacturing output, and also run the database check. You can run the database check when some strange effects occur on your designs. And this is also always the first thing when we get a board on the hotline, that we run the database check. In most cases, or in many cases, this also solves the problems here. And please don't ask me why the checks are not turned on by default. I never understood this, honestly. yeah, but this is really nice thing, database check, and yeah, I think many people are aware of this. So when you face an issue with especially a big board with lots of components during moving, especially moving or placing components, then this can be the case that in the background this AutoSilk process is already running. So if this is here turned on in the AutoSilk, then this AutoSilk generation or regeneration, I must say, is running in the background, always online. And this can really slow down the PCB editor. So, and we quite frequently this issue is reported on the hotline that the PCB editor is really reacting slow when moving components. And yeah, these are three different things you should check. If you're facing these issues, we can also provide you an application note where this is described in more detail. But in most cases, I would say 90% of the cases, it's the AutoSilk process which is running in the background and slowing down the moving of components. Good, and then now last slide of the slide deck before we enter PCB Editor, and I show you some things inside of the tool. And I would say this is the most important slide of this webinar. Please do not use special characters. We have so many cases on the hotline with a space or something inside of a path name or inside of a value or something like this, and this leads to strange effects inside the tool sooner or later. So for example, which is quite frequently happening in the last time, is that these InDesign analysis flows are not working. So impedance analysis, something like this. These flows really don't like special characters in the path or in the file names. So, and then sooner or later you will run into problems, and that's why we clearly say this is really our recommendation: do not use special characters. Good, so much about the slide deck. Then let's go into the PCB editor, and then I can show you some things inside of the tool. So I will show you some things first here in this design, and afterwards switch to another design for the XNets stuff. So first, SnapPick 2. We have here a component, and this component should be aligned here to the place keeping, and also to this line, to a guideline I have here for placement. And if you see, yeah, you can move this guy around, but it's really hard to place it at the exact spot where it should be. So, and that's why we can use here SnapPick 2. And if I do this again, select this guy, and then here use right mouse button, click SnapPick 2, and then vertex, then it's attached to the mouse on the vertex. And I can here now again SnapPick 2 and use intersection, and then it's directly perfect at the place where I want to have this guy. And you have seen, it's not required to change the grid or something like this, because this is really cumbersome thing, always changing the grid. But SnapPick 2 is really nice and very, very precise to work with that. Good, then let's go to a different spot, and let me turn off the package, the place bound, excuse me, because we don't need it anymore. It's just disturbing us. So now this snap to connect point doing the routing. So this guy here. When I start to route here now, and I do this by intent, not really in the center of the pad, it's always the line, as you see, it's always snapping to the connect point. And if you turn this off, you can start routing, and you directly have generated the DSC, because the line is not connected to that pin, and therefore it doesn't get the net information of that pin, and you have no connection here in the end. So, and that's why our recommendation is always keep here snap to connect point, leave this on. This is quite an important thing here, which makes your life easier. Good, then let us have a look at this different drafting utilities. Let me go to this spot here inside of the board, maybe like this. So then we have here under manufacturing drafting, and we have, for example, here this delete by rectangle. So now I can select a bunch of lines, draw simply a rectangle, and delete it. This is just somehow a nice thing here. manufacturing draft, or maybe delete by line. I select now maybe some C-line segments, these guys here, draw then a line, and then I have to select which side of this line I want to delete, and then we can delete it also like here in a diagonal way or something like this. This is quite a nice thing. As mentioned, there's a little bit hidden because normally this drafting utilities should be under edit and not under manufacturing. So also you can add parallel lines here. For example, let me add here 3 of these guys, something like this, and you have 3 parallel lines directly with one mouse button click. So it's really useful and nice feature, I would say. Let's have a look at the fixed and the locked properties. So I have here, oopsie. So now I have here something prepared. So for example, this first thing is here on this component. Let me adjust the fine fill, that's fine. There's a fixed property, and you see it's okay. Toolless reporting says fixed property. You cannot move this guy. The other guy here, this has a lock property, and you see I can move it around inside of the board. But what I cannot do is changing some things inside of this guy. So, and if I, for example, use move and adjust the fine filter, for example, here to lines, and do this on this other guy here, then you see I can destroy this component because this is not locked in itself, so to say. And that's the nice thing of this lock property, and as mentioned, especially useful for modules which should not be changed afterwards. Good. Yeah, then maybe coming to the net short, I have something here, and let me turn on ground layer, ground earth layer in the end. So, and you see here this blue net here. This is analog ground, and the plane here on layer 2 on the ground layer is ground earth, and these guys are connected here at a dedicated point. And this is exactly what the net short property makes, and this is in this case on a via. And you see here the net short property, analog ground and ground earth, separated by a column. As the value of this net short property, take care that they are shorted in this point. So, and if we remove this guy here, this net short property, then we directly see, okay, now the plane is cut out because this net should not be shorted at this case, at this point. So this is net short property. So then let's make this bigger a little bit again, and coming to the visibility. So I'll turn this off again. As you see here, I have set here this user preference for the shapes, and now you can control, in addition, the visibility of the shapes on a layer. So you already know here this edge is hiding everything, so shapes and also the connect lines. If you just want to hide the shapes, then you can use this guy here now. So this is also a nice feature, sometimes really useful, that you don't see the shapes. Good. Coming to the different controlling possibilities for the shapes. So first, the dynamic thing here. Let us have a look here, for example, at this shape and especially at these SMD pins here. So inside of the shape menu there, we have this global dynamic shape parameter. First thing here, normally this dynamic fill, you should leave it on smooth. If you have really big boards with lots of layers, lots of shapes or something like this, it can happen that the tool is slowing down again a little bit. If this happens, then you can also switch this to fast. So in the end, it looks more or less the same, but the calculating algorithm in the background is a little bit faster. So this you could do. So, but more important here is these settings, what I want to talk about now. We have here these settings for the shapes, global dynamic parameters for through pin, for SMD pin, orthogonal, or like orthogonal. So also for the vias, and that's why, for example, this via is connected in an orthogonal fashion here. So, but you see here, for the SMD pins, this is diagonal. So how is this coming? This is coming from the layer dynamic shapes, And here I've set for the outer layers, so top is obviously an outer layer, this SMD pins like diagonal. So, and that's why these two VDD pins here are connected in this fashion, diagonal fashion. And you can do this, yeah, as mentioned, for layer groups. Also, you could set this for individual layers. That's also possible here. So, and if this is still not enough, we have the possibilities to control this by properties. And I do this now on this pin, for example. And what we have here, we have tons of properties for sure. And we have also a bunch of properties for the dynamic shapes, for the behavior here. And these are always these dünn properties. So, and I will not go through the complete list. It would be too much here for this webinar. So let me just as an example show you this dünn thermal con type property. And if we use this guy here and, for example, set this for top to full contact, and then we see what is happening here. We see this guy here, this pin is now connected in a full contact fashion to the plane. And this is now coming from the property, which is overwriting all the other settings. The settings coming from the global dynamic parameters, from the layer dynamic parameters, also from the instance parameters, which I didn't show here now. Good. Let us talk about the possibilities to control the spacing between a C-line and the shape in a region. So I have here a region, and in this region, special rules are set up. So a smaller spacing between the C-line and the shape in the end. So 0.3. It should be 0.3 here in the default area, and here 0.1 millimeter in this constrained region. But you see, it's always the same here. So, and if you really want to have this solved in the right way as you want to have it, we have to set the property on the complete board drawing. And this we can do. So I select now the board drawing, and we have again here a few of these dynamic shape controlling parameters. And in this case, this is this dünn shape void C-line region. And if I apply this, and if I now update this shape, we will hopefully see what's happening. Yeah, we see it. Now here is the spacing used, which is coming from the constrained region settings, really. So, and yeah, and sometimes this is required, but yeah, many people are not really aware of this possibility to add properties really on the complete board drawing and not just on a dedicated object or something. Yeah, this is really a nice feature now, and as mentioned, this is available since a longer time, but it was a user preference before. And now it's a possibility to control this by a property on the board drawing. Good, and last thing which I wanted to show you in this board is this adjacent layer cutout thing. So let me turn on again this ground plane here, and then we see here this guy here, this pin is cut out obviously in the ground plane. So, and how can we achieve this? So first we have to set this up inside of the pad stack. Let me open the pad stack, and we see here we have here defined an adjacent layer keep out. And this is defining the size of this cutout inside of the plane layer. Good, this is the first thing you need to set up. And the second thing is, again, a property, and this property on a pin. And then we see here this adjacent layer keep out below. And I set this to 1. So this exactly means that only one layer below this SMD pin, there this plane is cut out. So these two controlling possibilities or requirements how to set this up are required there. So first setting the size inside of the pad stack editor, and then setting here adjacent layer keep out above or below inside of the properties of the pins to really enable this cutting out. Good, yeah, so much about this board. Then let me switch to another board where I can show you some of this XNet stuff. So in this case, we have here a driver U1 serial resistor and the receiver U2. So, and obviously now have a look at this nets here. We have here net 1, and this guy is member of XNet net 1. And also here, the second net here, net 2, it's also a member of the same XNet. So the XNet has been generated automatically by the tool through these passive components R1 and R2. And what we also see in addition here, there's a second resistor on both of these nets, connecting them to ground. So pulling up resistors, for example. So, but obviously ground is not included in one of these XNets. And this is exactly controlled by this voltage property. So as soon as a net is a power net with a voltage property, the XNet generation is stopped at this component. So, and this makes perfect sense, as mentioned. When you want to constrain these kind of things, then you have to constrain the, for example, the flight time from this driver to this receiver and not a flight time through a complete ground net or something. This is useless. So this is the first thing here. So, and the second thing is here, what I can show you here, we have here some additional nets. So this is net 5, this is net 6, and this is here net 7, and next 7, and here in this other side, net 8, they are net 8, they also form an XNet through these active components. And this is here controlled by the XNet pin properties, which I can show you in a second inside of the constraint manager. So this is the second possibility to control this stuff here. So let's have a look at the constraint manager. There we can see this all. So first of all, and there are also lots of questions coming on the hotline regarding this. When you have XNets inside of the board, then typically this looks like this. So you don't see some of the nets anymore, but you see just the XNets. So for example, here net 1, net 3, net 2 and net 4 are somehow hidden. They are still inside of the board for sure, but they are by default hidden inside of the constraint manager. So, and many people, yeah, they think, but I want to constrain my net, not my XNet. I don't take care about any XNet. They don't, are not simply not interested in these kind of XNets. So, and yeah, when you are not interested in these XNets, then you can simply filter them. So turn them off. And now you see all your nets, no XNet anymore, and you can set the constraints on your nets. And the XNets are there in the background, but don't disturb you in any way. So that's the first thing. And this is really a frequently asked question on the hotline. So if you don't want to use them, yeah, simply switch them off, or turn them off, or turn them invisible, I must say. This is more precise. So, and if we really want to see what's really inside of the XNets, then we can also turn the nets inside of the XNet on by nets of XNet, show net of XNets. So, and then you see, now we see everything. Now we see the XNet, net 1, and the 2 nets underneath this, and also here. So, and yeah, this is, as we are now talking about XNet, the best filter option, so to say. So this is the first thing here. So, and if you really want to control this stuff, then you can also do this by the no XNet connection, for example, on components. So I have here selected properties component and general component properties. And now I turn on, for example, this property, no XNet connection on R2. And then hopefully we see this right away, what's happening. We see it more or less good. And now we can use this regenerate XNets here inside of the database check, so like this. And if I go now to the constraint manager, again, we see this here as it should be. So net 1 is still an XNet with net 1 and net 2. And net 3 and net 4, they are not grouped into a XNet anymore, because of this no XNet connection property I just put on this resistor. So, and the other thing what I also wanted to show you guys is the XNet pin properties. And I set this up here on this U2. Remember, there were 2 pins with an XNet pin properties, and this is this XNet pin property, and that's why this net 7 and 8, or what it was, these are forming this additional XNets here. So far so good. So this is completely automated. You don't have to take care about the XNets. If you're not interested in these guys, simply turn them off. So, and then in addition, there is this more or less hidden possibilities to switch the flow here. Remember this environment variable for this. And here, as mentioned, you have to be careful a little bit. So normally it's not required. Normally always stick it to this create XNet for passive devices and for devices having XNet pin properties. So let me show you what's happening here. If I switch this, so I switch now to DML models. And now you will see when we have a look at the nets again, there are no XNet anymore because XNet generation is now controlled by DML models. So as mentioned, this is additional effort to maintain this. So and therefore, the normal methodology using here this XNet pin, this XNet for passive devices and for devices having XNet pin possibilities is the most comfortable way. So and what I also would like to mention, when you switch this back again, then there will be some additional properties. So like here, now these resistors get these XNet pin properties and no XNets are generated through these passive components because of these different XNet pin properties. And this is happening when you switch these flows. And that's why we say our recommendation, don't switch this flow, always leave it on a default way of generating the extended nets, the XNets. Yeah, so far so good. That's basically what I wanted to show you inside of this webinar. As mentioned, there are some additional links inside of the slide deck. So when you have the handout, you also have the links to our homepage with tips and tricks. For example, this is the Cadence tips and tricks document. This is a little bit older, but most of the things are still valid somehow. And also, a link to our general download page where you can find lots of different application notes and these kind of things.
Yeah. That's it. No more questions anymore, or is there? If yes, please, you have always the possibility to contact us.
Yeah.
So thank you very much for your interest. I hope you all get some part out of this webinar. See you soon. Have a great day. Thank you.
Thank you. Bye.
Bye.